We're looking at a problem that we're going to set up, and we're going to solve using inverse matrices. We have a manufacturer of portable tools has 3 sets, Basic, Homeowner, and Pro, which must be painted, assembled, and packaged for shipping. The following table gives the number of hours required for each operation for each set. So if the manufacturer has 98.2 hours for painting per day, 68.5 hours for assembly per day, and 58.7 hours for packaging per day, how many sets of each type can be produced each day? So the first thing we'll need to do is come up with some equations, and then we'll use matrices to actually solve the problem. So let's come up with our equations here for our problem. So we have 3 different types, Basic, Homeowner, and Pro. So it looks like the painting, if we look at painting, it takes 98.2 hours per day. If we look at our painting over here. And so I have 1, and I'm going to let my basic be X, plus 1.7Y be my homeowners, plus the 2.8Z be my Pro, and they have 98.2 hours for painting. So again, if we go across, this is the painting, and then the next section is assembling, which is 0.8 for basic, plus 1.2 for homeowner, plus 1.9 for pro, and they have for assembly, looks like 68.5 hours. Helps if I look there. 68.5 hours for assembly, and then packaging is the last that we have, and we have 0.7x plus 0.9y, and then 1.7z, and there is 58.7 hours. So we come up with our equations here. Now again, remember the x's are our basics, and this is the homeowner. And then the last one is the pro here. Okay, so that's my y, that's my x, and that's my z. You could use any variables as long as you remember which one's which. So here's where we can set up our matrices. So if we're going to use inverse matrices to solve this problem, I need to find the inverse of, and we'll use my coefficients, 0.8, 1.2, 1.9, 0.7, 0.9, and 1.7. And then we can just set it up with our variables, and that all equals 98.2, 68.5, 58.7. So what I need to do is find the inverse of this matrix, and then once I find the inverse of it, I will use it with what we have here, this 3 by 1, and then we'll find our solution to this problem. Now instead of finding this inverse by hand, which we could do, it would take some time, we're going to use our TI-83 that's available to us, and we're going to put these matrices in and solve using the calculator. So I'm going to go second, matrix. I'm going to scroll over to edit, hit enter. This is a 3 by 3, right? 3 rows by 3 columns. 3 rows by 3 columns. So it's a 3 by 3. And you can see I have it in there already. And how you put matrices in here, I would just do 1, enter, and it'll move over to the next one. And we would do 1.7, enter, and so on until I have our matrix in. So I already have it in there just to save us some time. Second, quit. You want to get out of that altogether. And we're going to put in our next matrix our answers here, or the times that were given to us, how much time they had to work. Go back to matrix, second matrix, edit. This time I'm going to scroll down to number 2, enter. This is a 3 by 1, 3 by 1, and again you can see I have entered those in there. And again 98.2, enter, and then you would do 68.5 and 58.7. So now we have both of these in there, our matrices. And using the inverse, we're going to find the inverse of this 3 by 3 and then multiply it by our answers, or what we have here to come up with our solution for the equation. You know, just how many of each product can be produced with these hours and the time it takes to produce each type of product: painting, assembling, and packaging. So let's go ahead and do that. So I'm going to go second matrix. This time I'm going to say right here, I want that 3 by 3, enter, and I'm going to do the inverse of it. So I'm going to click on this x to the -1. So that will give me the inverse to this matrix. Then I want to multiply that times second matrix, go down to matrix B. So I have it set up to where I'm taking this matrix, I'm going to find its inverse, and then I'm going to take its inverse and multiply it. And we can do all that in one step. And there's my solution. It looks like it takes, how many? Looks like we can produce 10 of the basic, 14 of each type. Again, and here's my X, Y, and Z. So this would be 10 of the basic, 14 of the homeowners, and 23 of the pros that can be produced for what we're wanting.